everyone, welcome to our lesson on inverses of functions. So for this lesson we're going to talk about 3 different ways that you can find inverses of your function. One is by using a set of ordered pairs, and one is for if you're given an equation, and the third method we'll talk about is graphically. So we'll get started. Let's take a look at this set of ordered pairs here. We've got a diagram showing x values for our inputs and y values for our outputs. And if you're needing to find the inverse using a set of ordered pairs or a table like this, it's very simple. The only thing you need to do is to switch all of your x and y values. So you can see here for an original list where these are our input x values and these are our y values. To find the inverse, we'll just switch them all. So our x values need to become our y values. You can see that that's happened over here on the right. And our y values have become the x values. Very simple, just switch them and then you can do whatever you need to with that. You can go graph the new set or list it as a set of ordered pairs. Alright, if we are given an equation, this is our second method for finding an inverse, then we can use this 3-step process to find its inverse equation. What we'll do is we will replace f of x with y. Typically the equations have the f of x in the front of the equal sign, and that's just the equation's name, f of x equals, and then they'll have whatever the expression is. So if that is there, we're going to replace it with a y. However, if you already see a y there, that step is not necessary. And then you want to proceed and switch x and y, and then you're going to solve for y, wherever the new location of y is. We're going to take a look at an example using that method. So here we have a linear function, f of x equals 3x minus 4. And remember, our first step was to replace f of x with y. So y will now be in the front instead. Very simple. So first step's done. Second step was to switch x and y. We're just going to put x where y used to be, and y where x used to be. Again, simple and done. And now y is no longer by himself, so we need to isolate y, and because the third step was to solve for y. So let's use our opposite operations to do that. So we need to add 4 since we see that we have a minus 4 on the outside here. Add 4 to both sides. Working on step 3 here. So I've got x plus 4 equals 3y because these will be gone. Last thing is to get rid of that 3. It is being multiplied by y, so we're going to divide it to make it go away. So we have y by itself. Let's write it by itself on the left-hand side, just to be consistent with the form that we saw in the original problem. So y equals, I can leave this as x plus 4 over 3, or we can separate it to be the x term first. Looks something like this. So we have now found our inverse of the function f of x equals 3x minus 4. Alright, we want to try this one more time because we want to make sure we remember this process. This is the longest process out of the 3. We've got one more example. First step was to replace f of x with y. So I'm going to rewrite this equation doing just that. You remember the second step? That is what we're going to do now. We're going to switch x and y location, just the letters. You don't want to carry anything else with them. You don't want to bring any signs or powers, just simply the letters themselves. So when we do that in this equation, we're still going to have everything else that was attached to the variable still there. Alright, so we have switched x and y. We now need to solve for y. We need to get y totally by itself. So I'm going to work on step 3 and all this space down here. So we're going to add 8. Opposite operation. Got x plus 8 equals 1/4 y squared. These 8's are gone, so that's good news. And to get rid of our 1/4 that's attached, we're going to need to multiply by the reciprocal, 4 over 1. Both sides. Alright, so we'll have a little bit of distributing to do here. So I've got 4x plus 32 equals, these fractions are gone, y squared. Alright, we are still not done because we don't want y squared, we just want y. So to get rid of a squared power, we're going to need to use a. We're going to take the square root of both sides, and now we're done. We just need to rewrite. Y equals square root of what we see over there, 4x plus 32. And again, I'm just bringing the y to the left-hand side just to be consistent, just for consistency. So here is our inverse function of f of x equals 1/4 x squared minus 8. Okay, our last method to take a look at here is to look at inverses on the graph. What does that look like? If we're given a graph, we need to know that we can use either of the two methods that we just discussed, or we can know that inverses are reflections of each other over the line y equals x. And so if we can just reflect our picture over that line. Alright, so we have a couple of options. We can do that pretty easily if we can see clear-cut points on the coordinate grid. Remember, the inverses are just all the x and y values are switched. So if we can see those, we'll just switch them. And our second option, was our second method. If we're given the equation, we can do that three-step process for finding the inverse and then go plug in some values for that function. Okay, so let's say that we can see our graph. Let's say we've got maybe y equals x squared. Just stick with something simple. A quadratic function. So that's going to look something like this. Go through the point 0, 0 and several others. We know it'll go through 2, 4 and negative 2, 4. So if I can see that, I can take those 3 points and I can switch the x and the y values. So instead of going through the point 2, 4, this one here, my inverse will go through the point 4, 2. So I'll go plot that. And 0, 0 is still going to be 0, 0 when I switch around, so my function is still going to go through, or my inverse is still going to go through that point. And then the original graph here has the point negative 2, 4. So if I switch that around, it's going to have the point 4, negative 2. My inverse would actually look something like this. The green one is the inverse of the purple original function. We used the method of switching our x and y coordinates there. Now let's say that we're given a real problem here. We're given a function 1/2 x minus 4, and that's a linear function, and we are charged with graphing the inverse of this function. Well, since we can see the function equation, let's go ahead and use our three-step process for practice, and then we will go graph this. So first step, replacing f of x with y. Alright, next step, we're going to switch x and y. The last step was to solve for y, so we were going to be adding 4. Got x plus 4 equals 1/2 y. 4's are gone on the right-hand side. Last step here, we need to get rid of 1/2. We will multiply by the reciprocal, 2/1 on both sides. When we do that, let's come up here. We will have 2 times x plus 4 equals 2 times 1/2 y. Those will go away. So we need to do a little bit of distributing, and we will have our inverse expression here. So 2x plus 8 y. Go ahead and put that y on the left-hand side. And we have found the inverse for this original function. So let's go graph and see what this looks like. So y equals 2x plus 8. Using our slope-intercept form, we know that the 8 is our y-intercept, so we can go ahead and go put a point there. And it has a slope of 2/1. So we will move up 2 and over 1 to find each additional coordinate. You can also make an xy table of values there to find out additional points and then go ahead and connect. And we have found our inverse graph. We know that this is correct because the inverse still ended up being a linear function. And so what came out was a line, so that is good news. So this concludes our lesson on inverses of functions.